So I just finished lecturing on least squares. Remember what least squares says is that if you're looking at an inconsistent system, you shouldn't worry. All you need to do is look at the least squares problem. The least squares problem says instead of looking at ax equals b, look at grammian of a times x hat equals a transpose times b. So I have some code here which will help us do that. In this first cell, we have to put input two inputs. We input a matrix A and a vector B, and then I have a bunch of print statements which we'll just read once we evaluate. Okay, so the first thing that'll print out is the system that we're studying, A augmented with B here. So the A I've input is this 4 by 3 matrix, and then we're augmenting with this vector 2, 0, 3, negative 4, and R4. In the next print statement, we will reduce that system. And so when I do the row reductions here, what I find is that system is inconsistent. So that system is inconsistent, and before I learned about least squares, I would kind of worry because I'd say, well, I really want to solve this thing, but it's not solvable. What do I do? Least squares says, don't worry. Instead of looking at A augmented with B, we should look at the grammian of A augmented with A transpose times B. And that's what comes out of this third print statement here. Now we can row reduce that least squares system. And when we row reduce here, we do get a consistent system. Here we're finding that the x hat in the least squares solution is 2, 0, 1. And in the last print statement here, what we get is the error. Remember, the error is b minus a times x hat in length squared. So in this case, we get 7. This is exactly the calculation we did in the lesson. In the second computational cell here, so what this will do is this will fit a line to some data points. So here, all we have to do is input all of the data points in 2 dimensions that we are interested in, and then the rest of the code will construct the least squares system that constructs the line of best fit to the data. So the data points that I've input here are 1, 6, 2, 5, 3, 7, and 4, 10. So let's click evaluate here and see what happens. Cool. So the first thing that prints out is it tells me that the points that I input are the rows of this matrix. 1, 6, 2, 5, 3, 7, and 4, 10. Then the code calculated the line of best fit, the least squares line of best fit, and what it found was that the least squares line of best fit is 7/5 t plus 7/2. So here the slope is positive, 7/5, and the y-intercept is 7/2. And finally, the code will automatically plot all this data. So we have our 4 data points plotted here, along with the line of best fit. And we can sort of see, like, this is doing something smart. It's sort of cutting through all the data points in an intelligent way. Of course, we could add points here and reevaluate if we wanted to have some fun. So what if I added on the point, I don't know, what would be interesting? So what if we tacked on the point, like something way down here, like maybe like 5, negative 3 or something? If I tack on the point 5, negative 3, let's look and see what happens to the line. It turns out that's sort of enough anchoring down to change the direction of the line. So here we no longer have positive slope. The slope is now negative 13 over 10. Again, we can play around with this all we want. So instead of negative 3, what if I just put like 0, 5, 0? If I reevaluate, I'm still at a negative slope. So now the slope is negative 7 over 10. What if I went to, I don't know, I'm just having fun at this point. What if I input like the number 2 here? Let's see how it changes. So, now I'm still negative. It's still slightly going down. So this one point is heavily skewing my line down. Whereas when I didn't add on that last point, and I click evaluate, so this is the original data, I had a positive slope fitting this data. So there's a whole bunch to say here, and I'm not really interested in going into the theory of why someone might fit a line to data, that's up for the scientists to think about. But what we're doing as mathematicians is we're saying, okay, if you do want to fit line to data, here's a very sensible way to do it.